The sci-fi dream of flying around in pods high above the city might just become a reality soon. The unmanned test of a two-seater Lilium jet in 2017 gave its creators the push they needed to forge ahead with plans for a five-seater model for air taxi and ride-sharing. And now they're working on a seven-seater model. The egg-shaped aircraft can be powered from your wall socket and take off from your front lawn. It can literally fit in the same space as your car. Sounds good? Well, don't take your wallet out just yet. The eVTOL industry is cutthroat, with companies offering better, faster, more efficient jets left, right, and center. The last 12 months especially have featured some of the fastest-moving technological advancements ever. You have Joby Aviation, with a range of 150 miles, powered by 6 electric motors. Their jet was awarded military airworthiness approval in 2020, and they are now developing a civilian version of their aircraft. You have Archer Aviation, a Palo Alto-based company. They got a major boost when they signed a contract with United Airlines to provide them with 200 jets once they start production. They also recently announced a partnership with Fiat Chrysler to use the company's low-cost supply chain to accelerate the production of the aircraft. And that barely scratches the surface. Jaunt Air Mobility from Dallas, Texas, Volocopter from Germany, Whisk from California, and New Zealand, they're all in it to commercialize travel via electric jets. And one of the biggest players throwing their hat in the ring is Uber, and they definitely want a large piece of that pie. Uber certainly has the upper hand. They have an app and a well-established brand name that consumers recognize, so they're in a good position to break away from the competition. But Lilium Jet is a class apart. Lilium GmbH is a German-based startup company founded in 2015 by 4 aerospace engineers and product designers: Daniel Weigand, Sebastian Born, Patrick Nathan, and Matthias Meiner, all from the Technical University of Munich. They created Lilium to connect inner towns and cities about 24 to 124 miles apart at speeds of 175 miles per hour to help passengers save time. Their jets will carry the highest payload of passengers or cargo possible in the market, since it means improved operations. It would also let them offer competitive pricing to their customers. 20 years ago, a battery that could power a jet like this was thought impossible. But it's not without its challenges. Often, they have to fulfill contradictory requirements. For example, you need a high energy density battery to achieve long range, but a high power density battery to power takeoff and landing. To achieve this, they have not only looked at battery cells, but they've also studied all surrounding technologies. Now, they've developed a lightweight module casing that can contain the fire of an entire module and allows the aircraft to travel long distances and land and take off. What's more, their battery can be manufactured in existing supply chains, and they have a long life cycle and fast charging. Almost sounds too good to be true. As impressive as it sounds, can a full charge really give you 173 to 180 miles of range? Yep, and they plan to use off-the-shelf battery technology for it. Once the jet enters horizontal flight, which is the majority of the flight, the fixed wings generate lift, and that's basically free power. It means the plane will only have to use 10% of the engine power to maintain high-speed flight, and go much further than any aircraft being developed. Lilium initially got its funding from the European Space Agency and the European Union's Climate KIC program. By September 2017, they had more than $100 million, and in the last 3 months, they got a combined total of $370 million in new investments and are now valued at over $1 billion. They grew from a team of just over 40 engineers to a company of 350 employees. The air taxi startup will, in 5 years, have a fleet of jets shuttling people from Manhattan to Kennedy International Airport in 10 minutes for just $70 a seat. And yeah, that sounds ambitious, but Lilium's technology and designs make it seem possible. Rather than resembling a large drone, the sleek black and white jet is more of a carbon fiber glider with 4 rotating wings attached to an egg-shaped cabin. The Lilium jet looks different from everything else being developed out there. It has 2 fixed wings, one main wing at the rear of the jet that spans 11 meters, and a canard wing at the front of the aircraft, named so because it resembles a duck. This canard wing allows the jet to generate more lift and control the aircraft more effectively. Each canard wing has 2 flaps, and the main wings have 4. 3 all-electric jet engines are mounted on each flap, allowing them to independently pivot and change the direction of the thrust they create. It might look like it's missing some parts. Where's the rudder? The elevator? The tail? How does it balance? While designing the plane, engineers looked at over 20 existing concepts before realizing they didn't want to incorporate any of them. They needed a level of efficiency that pushed the limits of physics, delivered in the simplest, cleanest way possible. So, instead of tweaking an existing design, they started from scratch. You won't find tails, rudders, oil circuits, gearboxes, or variable pitch fan blades on this jet. Removing all that, believe it or not, makes the aircraft safer, more robust, easier to maintain, and it lowers the cost to certify, manufacture, and operate. The jet remains balanced thanks to the engine casing, so it doesn't need a tail. It performs the function of aerodynamic control and acts like the ailerons and elevator on a standard aircraft. It has 36 small engines that act as thrusters, meaning that it can take off and land like a helicopter with a 36-foot wingspan. 36 probably sounds like overkill, but it keeps the jet efficient, safe, and easy to maneuver. How? The engine casings are part of the wing that creates lift, which means engineers can reduce the surface area of the wing and the associated drag. Integrating the engine into the wings helps with that and allows you to distribute power along the wing to increase efficiency. Increasing safety is, well, thanks to all the engines it has. With 36 independent engines, you can reduce the likelihood of plummeting to the ground should one little engine fail. Lilium also has the safety grade of a commercial airline. The safety of large aircraft is generally measured in terms of possibilities of disastrous failures. For this 7-seater jet, the probability is less than or equal to 1 in a billion flight hours. This electric jet is easily 15 times safer than road transportation. And the jet aircraft becomes easier to handle since it uses smaller engines. It takes much less time to increase and decrease power in a small engine than in larger airplanes. There is more control and better response as a result. In fact, Lilium developed its engine in-house, and it's capable of powering up from zero thrust to maximum thrust in less than 1 second. Oh, and there's the comfort factor too. Because the jet's engines are encased in the wings, it's much quieter than your traditional helicopter. It's also quite spacious, enough to comfortably seat 6 passengers on large window seats with room to stretch their legs. There will even be an additional hold for luggage. According to the founders, each Lilium jet one day will cost several $100,000, and insurance companies already have told them they'd provide him with risk coverage in the future. In addition to that, Lilium aims to make their jet environmentally friendly and a sustainable solution. That means zero emissions and creating a plane that can be scaled without compromising on its values. Now, a common misconception of eVTOL jets is that they have to resemble helicopters. You know, the way they hover for a long time. But the actual goal is to connect 2 points on a map in the fastest and more efficient way possible. Keeping that in mind, the focus when developing this jet was to maximize time spent in cruise flight and minimize takeoff and landing time. Lilium has now partnered up with aerospace manufacturing giant Honeywell to develop electronics and mechanical systems for their 7-seater jet. They are set to supply their compact fly-by-wire system, a flight control component that controls all of the jet's moving parts, and the aircraft's avionics system. Honeywell is one of the first companies to develop a dedicated urban air mobility team, and it seems like the two companies have been in talks to collaborate since 2019. While the core components of the jet, like design, assembly, propulsion, and battery, will be made in-house, Lilium will rely on experienced suppliers to source parts for the aircraft. One key advantage here is the partnership will speed along the certification process. Many of Honeywell's components have achieved a technical standard order, which is a minimum performance standard recognized by the Federal Aviation Administration. So using already approved parts will save time in the certification process for the jet. It's clear to see Lilium is moving away from the limitations of traditional jets and embracing newer technologies and pushing the boundaries. And it seems many other companies have to start playing catch-up because their designs are a feat of engineering. We are now approaching a new chapter in aviation history, comparable to the development of large commercial planes in the 1960s. Regulators are once again laying down the foundations for an entirely new category of commercial aircraft, and we're looking at the possibility of our lives becoming a little easier and a little more efficient. Before long, actually, as soon as 2024, we may have a sky dotted with eVTOL jets. If you enjoyed this video, don't forget to subscribe to Tech Monster and check out more like it on the channel. Thanks for watching.